Welcome, team. Today we are tackling the foundational phase of GenAIOps, creating and configuring Microsoft Foundry resources and project environments. Getting this architecture right is the key to scaling your enterprise AI securely. Let's get started. Let's start by defining our core workspace, the Microsoft Foundry project. What exactly is it? It's a secure, isolated environment designed specifically for developing and operationalizing generative AI agents. In the basics of GenAIOps, this is where your team lives. It's the collaborative space where your code meets the language models. Why do we isolate these environments? Imagine a healthcare organization building both a patient-facing agent and an internal HR bot. You absolutely must prevent data leakage between these domains. Projects provide that strict boundary. How do you spin one up? You can provision them manually in the portal or automate it using tools like the Azure template for rapid deployment. Diving deeper, it's crucial to understand that a project doesn't exist in a vacuum. It sits inside a parent, AI hub, inheriting all its enterprise-grade security and networking rules automatically. This allows your developers to build safely without worrying about the underlying infrastructure. Take a look at this structural flowchart. At the top, we have your overarching Azure subscription. Flowing down from that is the Azure AI Hub, which acts as the central management layer. Notice how the hub branches out into distinct Foundry projects, one for an HR agent and another for customer support. Because they are separate project nodes, the project-specific data at the bottom remains completely isolated. The HR bot cannot access the customer support data, and vice versa. This diagram perfectly illustrates how we balance shared corporate governance at the hub level with agile, secure isolation at the project level. To configure environments correctly, we must master the architecture between the AI hub and the project. What is this relationship? It's a parent-child hierarchy where the hub governs and the project executes. The basics dictate that your central AI hub holds all the primary connections, your Azure OpenAI endpoints, your storage accounts, and your key vaults. Why is this our best practice? Because duplicating these resources for every single AI app would cause your cloud costs to skyrocket and make security management a nightmare. How do we implement this? Your IT team configures the virtual networks and private endpoints once at the hub level. Then, when your data scientists create a new project, they just attach it to that hub. For a deep dive, this maps perfectly to the cloud adoption framework. The hub represents your platform landing zone, enforcing rules, while the projects act as the application landing zones, giving your app teams the agility to build fast. This architecture diagram highlights the efficiency of the hub-and-spoke model. On the left, enclosed in the orange boundary, is the central AI hub. This is governed by IT and contains the expensive, secure resources, the Azure OpenAI endpoint, the key vault, and shared storage. On the right, we have our individual application workloads, Project A for marketing and Project B for finance. Notice how arrows flow from the central resources to both projects. Neither project has its own dedicated OpenAI endpoint. Instead, they securely share the centralized resources. This ensures compliance is maintained in one place while empowering multiple teams simultaneously. Once your project is created, an empty shell won't do much. You must configure its resources and tooling. What does this entail? It means integrating specific compute, vector storage, and orchestration frameworks directly into the workspace. The basics require you to establish secure connections to your models and data stores. Why? Because modern generative AI apps aren't just calling an LLM. They require complex retrieval-augmented generation, or RAG, which means your project needs a direct line to Azure AI Search and enterprise databases. How do you set this up? Inside the Foundry project interface, you navigate to Connections and securely link these external services using managed identities. As a deep dive tip, once your resources are connected, immediately use the chat playground in the portal. This interactive environment allows you to instantly validate your connections and test prompt responses before your engineers write a single line of Python code. Let's walk through the resource configuration flow. Starting at the top with our Foundry project, the first major action is the Add Connections node. From here, we branch out to link our essential enterprise resources. We connect Azure AI Search for data retrieval, Azure OpenAI models for our cognitive engine, and Azure Blob Storage to hold our raw documents. Once all three pillars are connected, they converge into the Chat Playground validation node at the bottom. This visualizes how disparate cloud resources are brought together within the project boundary to create a unified, testable AI environment. We have configured the project in the cloud. Now we must connect our code to it. We do this using the Microsoft Foundry SDK. What is it? It's a Python library that allows your applications to programmatically authenticate and interact with your AI resources. The basics of GenAIOps dictate that to move from manual prototyping to automated pipelines, your code must establish this link. Why do we use the SDK instead of just pasting API keys? Because hard coding keys is a massive security vulnerability. The SDK enforces zero trust, identity-based authentication. How is this implemented? You install the Azure AI Projects package. In your script, you define your subscription ID, resource group, and project name. For our deep dive, the true power is default Azure credential. When you pass this into your client initialization, the SDK automatically figures out the authentication context. It works seamlessly whether a developer is running the script on their local laptop or an automated GitHub action is executing it in the cloud. This sequence diagram demonstrates the secure connection handshake. The Python script starts by requesting an authentication token from default Azure credential. The identity service securely returns the token. Next, the script reaches out to the Foundry project, passing its unique coordinates, the subscription ID, resource group, and project name, along with the secure token. The Foundry project validates the identity and replies that the connection is established. Only after this secure, keyless handshake is complete can the script begin executing AI operations, such as model inference or automated evaluations. A critical part of environment setup is configuring the project for observability and safety. We must prepare the workspace for evaluation and tracing. What does this mean? It means ensuring the project has the infrastructure to capture telemetry and score AI responses. The basics involve linking Azure Monitor, specifically application insights, to your Foundry project. Why is this non-negotiable? Because generative AI is non-deterministic. When an agent hallucinates, you need trace data to debug exactly which step failed, and you need evaluation metrics to prove the fix worked. How do we do this? We enable tracing in the project settings and upload our evaluation datasets, formatted as SAML, into the project's data registry. Here is a crucial deep dive architectural constraint: Microsoft's advanced safety evaluators, which check for jailbreaks or protected materials, use dedicated hosted evaluation models. To use them, you must ensure your Foundry project is provisioned in a specifically supported Azure region during the initial setup. Let's trace how observability is layered into the project. From the Foundry project node, we move to Enable Observability. We take two parallel actions. First, we link application insights, which allows us to continuously capture deep telemetry traces of every model call. Second, we upload our SAML evaluation datasets. These datasets feed directly into the safety evaluators. Finally, both the raw telemetry traces and the structured safety scores converge into our GenAIOps dashboard. By configuring these resources up front, we guarantee that every deployment is highly visible and strictly evaluated. We have the tools and the observability. Now we must secure the perimeter. We do this by establishing governance and constraints. What is this? It's the application of strict role-based access control, or RBC, to your project environments. The basics of governance mean recognizing that not every developer should have the ability to push a model to production or read sensitive test datasets. Why do we enforce this? Because enterprise AI carries massive risk. We must protect our grounding data and prevent hallucinating agents from reaching live customers. How do we secure it? We use Azure's native RBC, assigning specific roles like Azure AI Developer or Inference Reader at the project level. Diving deeper, we orchestrate an agent governance swim lane. We don't just use one project. We create distinct dev, staging, and prod Foundry projects. We enforce rules requiring that a model must pass automated evaluations and staging, followed by a human approval gate, before it is ever allowed into the production project. This flowchart visualizes the governance swim lane across multiple Foundry projects. It begins with a developer push into the dev project for raw experimentation. Once ready, a CI/CD trigger promotes the asset to the staging project. Here, automated evaluations run against our locked datasets. Next, it hits the critical yellow diamond, the human approval gate. This is where governance is enforced. If rejected, it loops back to dev. If the security team approves the metrics, it is finally promoted into the strictly controlled production project. This multi-project architecture is the gold standard for enterprise risk management. Let's ground this in a real-time, highly practical use case. Imagine a company called Prosware. They need to build an AI customer service agent that retrieves company policies, and it absolutely cannot hallucinate return policies. How do they set this up? First, the IT team creates the corporate AI hub to manage the OpenAI billing. Then, they spin up a dedicated Foundry project specifically named Prosware Support. Next comes the critical configuration. They connect this project directly to an Azure AI search instance that contains only validated, approved customer service PDFs. The action phase begins with developers using the project's chat playground to safely tune the system prompt. Once the prompt is solid, they use the Foundry Python SDK to run batch safety evaluations against a curated SOL test dataset. The result, by strictly isolating this project environment and rigorously configuring its allowed knowledge sources, Prosware mathematically guarantees that their agent will only respond using trusted, authoritative data. Let's review Prosware's project configuration in this diagram. The Prosware Support project acts as the secure boundary. It connects directly to Azure AI Search, which in turn indexes only the approved policy PDFs. Inside the project, developers utilize the chat playground to refine the agent's behavior. This flows into the batch SDK evaluations node, where we rigorously test the agent's accuracy. Because the environment is locked down to specific data sources, the evaluations yield a high groundedness score, resulting in a seamlessly deployed, safe production agent. Our final step in mastering GenAIOps environments is automation. We must automate the configuration of our Foundry projects using GitHub Actions. What does this mean? It means shifting from clicking around the Azure portal to deploying infrastructure as code. The basics dictate that manual configuration is slow and prone to errors. Why is automation mandatory? Because if your dev project is configured slightly differently than your prod project, your model will fail in production. We ensure identical setups through automation. How? We write GitHub Action YAML workflows, triggered by a code push or a manual workflow dispatch, which use commands like asdup to provision the exact required resources. For a deep dive into security, never store static passwords in GitHub. Instead, configure federated credentials or OIDC between GitHub and Azure. This allows your CI/CD pipeline to request a temporary, secure token to configure your Foundry project, achieving total automation with zero trust security. This final sequence diagram illustrates the automated, secure deployment pipeline. GitHub Actions kicks off the process by requesting a short-lived token from Microsoft Enter ID via an OIDC federated connection. Enter ID verifies the repository's identity and grants the token no passwords required. GitHub Actions then executes the deployment command, passing the token to the Azure Resource Manager. The Resource Manager takes over, automatically provisioning the AI Hub, compute resources, and necessary connections within the Foundry project. Once complete, it signals back that the environment is fully configured and ready for the data science team.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment. Or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.